Is it better now? Thank you. So, Dima, thank you for the nice introduction. So, hello everybody, I'm Marijana Novakovic. I'm a staff network engineer on LinkedIn. I'm part of the global architecture and infrastructure team led by Zaid Ali Khan. And I'm handling interconnection globally, which includes peering also. So what are we going to discuss today? What is this presentation about? So we're going to discuss about what is LinkedIn, because I'm not sure how many of you know. And then the next part is why performance. Why performance is very important. And then we will speak about RAM. How do we do peering decision using RAM data? And of course, conclusion and future work. So about LinkedIn. So LinkedIn is a business-oriented social networking service, and it was launched 2003, Cinco de Mayo. Currently we have 24 languages. Some of them, we have 2 versions of Chinese, we have Japanese, and we also have Tagalog language. How many of you know what is a Tagalog language? Oh, great. Excellent. So for the other ones that don't know, Tagalog language is a language that is spoken by 60 million people in Philippines, usually in Manila mostly. So we also have 8,700 full-time employees in offices in 30 cities all over the world. This includes Tokyo, Dubai, Hong Kong, USA, Europe, and we hope many more. Currently we have only 380 million members in over 200 countries, but we still have a lot of work to do, so I'm crossing fingers everything goes fine. So now about the network part. So currently we have around 12 POPs all over the world. Most of them are in USA, and we are launching more and more POPs in Europe. For other continents, we have a POP in South America, we have POP in Australia, we have POPs in Asia, and we are currently deploying a POP in Johannesburg. We have 3 data centers of our own, and next year we are going to have 2 more, if not 3. So for the internet exchanges, so we are content providers, so we like to peer. Our performance depends a lot on the peering part. So currently we are on 26 exchanges all over the world, mostly in USA and Europe. The new ones we established this year in Sao Paulo, in Sydney, and soon it will come in Africa, Johannesburg. I'm really proud of this part. So why performance is important for us? So we saw that 1 second median latency increase, it means 15% engagement rate drop and 5% bounce rate increase. So what is engage rate? Engagement rate is percentage of the users that like, click, comment, or just see a post. And bounce rate is it's a percentage of the users that come to the web page, but they only stay on one page, and after that they just go away. So for 1 second, we see a huge impact, and we have to say, okay, we have to fix this. 1 second means a lot. So what can we do to improve the site speed? There's no silver bullet. Every company has their own way how to do things. So we have the same. We have our own specific way. Perhaps it matches with somebody else, with some other company, but not necessarily. So what do? We do several web performance optimizations. We do HTTP compressing. We do caching. We also do TCP anycast. We also try to build POPs. So this is a very specific story how we try to build POPs. We have a self-developed tool that is waiting to be patented. And it's like a spinning wheel. You spin it once per year, and it gives you the locations where you have to go. Those locations are geolocations, and they can be anywhere. And those locations mean that the performance of our website is really, really poor. So we have to come physically there. This means to build a POP, to pick a data center, and to try to find internet exchange in the same data center. And once we find the internet exchange, we hope it's very good exchange, that it has a lot of peers, especially the ones that can give us the availability to approach our end users. So we do like peering. So how do we select peers? What are the methods that we use? So we have ratio-driven methods, very classical ones, like net flow analysis. We use specific tools like Arbor or PMACT. We do a lot of pulse peering. So does anybody know what's a pulse peering here? So pulse peering is like peering where you have at least one pulse, anything, any type of traffic. So if there is any type of traffic, we will peer with you. What happens if you don't have traffic with us? We will still have to peer with you. We like to peer with you, but you have to make us really, really nice peering request. My favorite peering request was from PTT Sao Paulo, and it came something like, "Hi, I want to climb a BGP session with you. What do we do?" So obviously he was asking to peer. So the last method is performance data driven, and this is the part that we are going to discuss in the next few minutes. So RAM. What is RAM? RAM is the pirate's favorite drink. No. RAM is a passive monitoring system, and it recalls all the interaction that the user has on a website. Some of the measurements that you can do is TCP connect time or page download time. Some kind of alternative to RAM is synthetic monitoring, which we found out that doesn't work much for us, because one of the examples that synthetic monitoring can be Keynote, Gomez, or Catchpoint. So why why synthetic monitoring is not working for us? Because it does the periodic testing only in one part of the time, and it doesn't give you the complete picture. Also, when you have isolated performance issues like a traffic peak or third-party outage, you cannot see this part. Also, LinkedIn has their own specific things, like every page or for every user is different, it's not the same size, and so on. So synthetic monitoring usually used a lot for the cases when you do something in pre-production. But for the production side, we are very pleased with RAM. So how? How does RAM work? So RAM is like a library of JavaScript, and there is a navigation timing API that most browsers support. So those browsers are recording the performance times for each page load. It doesn't have to be a page load time. It can be completely something else. For everything else, we can use JavaScript timers. But usually, for our case, we are really, really pleased from RAM. I think I said it several times already. So if you want to try yourself, what is RAM, how does RAM work, you can go to the linkedin.com page, or you can take some other page, but for us, we use it. And you can open the console on Chrome. So here are the shortcuts that you can use. So once you go there, you will see a small window where you can type window performance timing. Window performance timing is like an interface that shows you a lot of events that you can use to measure the timing for specific things. So some of the events that you can check, I'm not sure, can you read properly? Can you read the small letters? Yeah? Okay. So some of the things are redirect start, redirect end, I don't know, connect start, connect end, etc., etc. So you see you have two variables, one is start, one is end, and if you combine them together, you will see that you can get time for almost everything. So in this case, we are going to use three things, three events: connect time, download time, and request to response time. So connect time, we have two variables, and we take away the connect start time from connect end time, and we will get a value in milliseconds. For the download time, we will take response start time, and we take it off from the response end time, and we will also have a value in milliseconds. And the same goes to the request to response time. So these kind of types, you can take whatever you want, whichever event suits you for your monitoring purposes. As I said, RAM is a really nice library from JavaScript, and it can be used for monitoring, for performance issue, to analyze a lot of things. So here is one example, how to find out what's the connect time and for what is the response time. So you see the number 136 milliseconds. As I said, this is just a simple elementary mathematics. You have two variables and you take away one from another. The same goes for response time too. Okay, so RAM data flow. So imagine you're a user and you're drinking your coffee, perhaps now in the morning while you are watching my presentation, and you are going to the LinkedIn page. So we already have RAM embedded, RAM test. So each time when you click on your LinkedIn profile, we collect the data. What do we do with the data? We feed Hadoop. So Hadoop, Apache Hadoop is an open source framework that can store and process huge amounts of data. So what do we do with this huge amount of data? So we analyze it and we make a peering partners report. Peering partners report we usually send to the peering team, that includes me, and it tells us what we have to do next to make the performance better. We will see more in the next slide. So, this is the example of the potential peering report. So, the first column you have ASN number, and you have page view in percentage. Page view in percentage is how many percent of the traffic goes through this ASN. So for the first ASN 7922, we have 7.8%. We also see the peering policy, the page views, and average connect time. Our goal is to have average connect time lesser than 100 milliseconds. But of course, it depends where you are, in which part of the world. You cannot have a perfect situation everywhere. You cannot compare India with or South Africa with USA. So once we get this peering report, we say, okay, now we have to go to these peers and we will try to pair with them. So as you see, most of them are already selective and so on, but this is our part. This is the part where you can't automatically do, but there are cases when most of the peers have open peering policy, and this means that you just push the button and it will generate the configuration automatically. Okay, so conclusion and future work. Please use RAM to make peering decisions. It works for us and it gives us the realistic view how our users behave. And what's the next thing to do? So we want to fully automate peering turn-up using ROM analysis. So we already have our peering tool that we use, and we plan to combine it with this one, which means that once the peering report comes, the peers that have an open policy will be automatically processed. There will be a peering request sent automatically to them. For the selective ones or restrictive ones, it's different. Then you have to negotiate, right? So in the end, what happens if peering goes bad? What if you have high latency? Then you have to think different way. You have to try to change the routing policy or spin the wheel that we have and perhaps try to deploy somewhere else. So that's it. Thank you for your attention. I hope it was very interesting for you. And just as a last thing, before the questions, I want to say special thanks to Zaid Ali Khan and Ritesh for making LinkedIn faster. Thank you.
Thank you, Marijana. Hvala. У нас наводки. Вопросы есть из зала, пожалуйста. Подойдите. И представьтесь, если можно.
My name is Alexander Shikov, DTLX Internet Exchange Point, Ukrainian. I have a question regarding real user monitoring. How can you trust to this data? As far as I understand, you get it from users' browsers, and this data will depend on PC performance, on performance of end user in connection to internet. How can you trust to this data, and why do you trust to it?
So we don't have a choice. In the end, the end user comes to us, right? So he's important. His performance is very important for us. So he's using some ASNs, probably some DSL provider, or I don't know what. So we already deployed. We have 1 year of results that show us that our tool that we developed for this is actually accurate to 10 or 15 milliseconds. Either when you deploy a POP or you make the performance better or the peering, the tool is not very wrong. So for us, this is a good way to say, hey, it's really working.
Thank you.
You're welcome.
Okay. And I also have a question. Could you go to your third or second slide with a list of IXs you are peering at?
Which one? Third or second?
Yeah,
okay.
that was at the beginning. Okay, previous one. So,
yes.
This one. Okay, I don't see any exchanges in ENOG region.
In where?
In ENOG region.
In your region?
Yeah.
That's
so would your visit here mean that you will go back to Dublin with some new peering agreements with IXs, for example, who will take
So
Partner
I don't
panel?
understand. I think I didn't understand the question. So you are asking me why you don't see your internet exchange here, right?
Yeah, and I have
Okay.
I wish you have such
Ah,
exchanges
okay.
and this list on your next
Thank you.
presentation.
Okay, thank you. So just a small answer to you. So it means that the current performance to the Ukrainian customers is really good. So we don't need to deploy a POP or go to the internet exchange. If something goes bad, perhaps if the number of users is getting bigger, gets better, perhaps the performance will go down or something like this. Then, as I said, we spin the wheel and then it will show us Ukraine and then we know that we need to go there to deploy a POP.
So it means that poor Amsterdam, New York users have difficulties accessing LinkedIn, but Ukrainian, Russians, maybe Moldovan, Caucasus users do not have any problems.
No, and
Our internet is
it's a
better
ratio. It's a ratio. It depends how many of you uses LinkedIn. So the more people uses it, we have the better feeling of the performance, right? So most of the users that we have are in Europe and USA. And as I said, if we have enough customers and if the performance is good enough, it doesn't have to be 100 milliseconds, we won't do anything. We have far more critical situations to deploy than Ukraine. But it will come, I'm sure.
Thank you.
Thank you.
Any more questions from the audience? Еще есть вопросы из зала, пожалуйста. Так, я тогда благодарю. Thank you, Marijana.